-4 minus 5 equals -9. Is this a difference? Is this a difference? Yes, because it's subtracting. Is one of my numbers negative and one of my numbers positive? Yes, one's -4, the other one's +5. And do they equal a number that is positive? No. So this is a perfect counterexample. Very good, Sophia. Did anyone do anything else? A different set of numbers? Cody, what'd you get? -2 minus 7 will also work. What do we get there? -9. Okay, we have to be pretty good at this stuff, finding counterexamples of stuff. These two would work as well. -4 and 5 also worked. Okay, number 7. If a triangle measures 180 degrees, each angle is 60 degrees. Was there a counterexample there? There sure is. Mario? 90, 45, and 45. There's actually thousands of possibilities. Did anyone put anything else? Marcus, what'd you get? 110? No. Because triangles have how many angles? 3. Cody? 70, 70, and 40. That also works. Because they add up to 180. Yeah?
So you have to have at least 2 that are congruent, right?
No. For any triangle? Is this... Oh, no, that's a bad one. Is this a triangle? Do 2 of the angles look like they would be the same amount of degrees? No. Okay? So, any triangle, they just have to add up to 180. We're going to learn more about that later, but as a counterexample, you just need to pick 3 angles that still added up to 180, but they were not all 60. Marcus? You're going to say another answer? 35, 35, and 110. Could I have picked 100, 50, and 30? Why not? 100, 50, and 30? I could do that, okay? Remember, guys, triangles do not have to have the same measure for their angles. Okay, they just need a total 180 degrees. Questions? Okay, guys, there's a ton of vocab in this lesson. There's literally 7 postulates right off the bat, okay? So if there's anything that you put at the top of this lesson, it's that all of this should be turned into a Quizlet and you guys should share it with one another and study that way. We Gucci? So someone take one for the team and make the Quizlet. Here we go. So this is chapter 2, section 3. We're going to be using postulates and diagrams. Here we go. Your first 4 postulates are these 4, okay? Now, listen. Don't write down right now. Listen to me and look me in the eyeballs. Guys, a lot of these postulates tell you exactly what they are just in the name, okay? So, look at the 2-point postulate. 2-point postulate. You're going to start with how many points? 2. Through any 2 points, there is exactly 1 line, okay? So, do you see how the postulate basically told you what was in there? Does it help if I zoom in? Can you guys see it better like that? Yeah. Or did I just highlight the worst in the world? Okay. Okay. For the first one, guys, it says through any 2 points, there is exactly 1 line. We're going to start with 2 points. So draw 2 points. And we're going to infer that through those 2 points, we draw what? A line. Now, let's see why this makes sense. Guys, is there another line that I could draw that would go through these 2 points that wouldn't be this line? No. No. So that's why there's exactly 1 line. There's no other line that goes through them. Does that kind of make sense? Because if I were to draw another line, it could only go through one of them. Do you see how this guy would only go through this one? Okay. There's only 1 line that can go through 2 points. Next one, a line point postulate. A line contains at least 2 points. So before we started with 2 points. Do you guys agree? Now what are we starting with? a line. And what are we saying is true about that line? There's 2 points on it. Okay, so draw a line and then draw a line with 2 points on it. That is the only assumption that we're making. That if we have a line, there's at least 2 points on it.
Hi there, can you please send Carson Kroll to Student Services? She's leaving.
Yeah.
Thank you.
Are you guys with me so far for the first two? The second one again? Okay, so line point postulate. It says, okay, imagine that there's a line, John. Here's your line. You see my pen? There's at least 2 points on this line. Do you agree? You could just pick any 2 points. That's all it's saying. Okay? Bye, Carson. Okay, next one. Line intersection postulate. If two lines intersect. Stop reading. Let's just draw that. So draw 2 lines that intersect. Do you guys agree that those 2 lines intersect? Yes? Okay, what's my conclusion? Their intersection is exactly 1 point. Draw those same 2 lines and put right in the middle. What are we going to draw? A point. Make sense? Do we know almost all of these postulates before we went over them? Like we could infer this information, but it has to be stated as a postulate. You're going to see why. Because when we start doing proofs in this chapter, you have to know exactly why they're going from one step to the next. You're going to have to prove all your stuff. What's that? It is challenging. I'll say it like that. Okay, 3-point postulate. Through any 3 non-collinear points, there is exactly 1 plane. Through any 3 non-collinear points, there is exactly 1 plane. What am I starting with? 3 points. Can my points look like this?
No.
Why not? Those are collinear. Do you guys agree? I could draw a line that goes through all 3. So I'm going to change one of the points and I'm going to put it down here. Can a line go through all 3 of these points? No. Absolutely not. Then what are we inferring from that? That there's a plane, right? So draw a plane. But my plane needs to have what?
Arrow.
No. The 3 points that I drew. So draw the 3 points. You guys see how this is working? Most of these postulates are conditional statements, right? If this is there, then this has to happen. Do you guys see that? So most of the time we're going to be able to draw our hypothesis and then infer something from it with an arrow. Yeah.
What is the third one saying?
Exactly 1 point. Questions? We Gucci? All right. Converse of the 3-point postulate. Do you guys see that? Next 3. There's 7. Plane point postulate. A plane contains at least 3 non-collinear points. This one's exactly the same as the last one, just in reverse. So now this time, what do we start? Is this better? Yeah. Okay. This time, what am I starting with, guys? A plane. So draw a plane with no points in it. And then based on that plane, what can we infer? That there's 3 non-collinear. So draw another plane, or the same plane, but just put 3 points in it. Yeah. What do you mean they're opposite? Very good. They're converses of each other. Do you remember what converse means?
Yeah, opposite.
But flip what?
Flip both sides. The Q and the P.
The Q and the P. So flip the hypothesis and the conclusion. So the plane point postulate is exactly nice. Good observation. Plane line postulate. If 2 points are in a plane, then the line that contains them is in that plane. If 2 points are in a plane, then the line that contains them is in that plane. What do I start with here? Marcus, I start with what? Not a plane and a line. That's what I end up with. A plane
2 points.
and 2 points. So draw a plane with 2 points. And my conclusion was that plane has what inside of it? A line that goes through those 2 points. Do you guys agree? I would agree with that. I want to show you this one as an example. Everyone look at the wall to the left of John. This wall over here. if there's a point here, for example, and a point over here, would the line that connects them, does that line lie on this plane? Yeah, that makes sense. It's still on the wall. Do you guys agree? Now, if there was a point here and a point here, are both those points on the plane?
No.
Would the line that connects them be part of the plane? No. Do you guys see the difference? Awesome. Okay, last one, the plane intersection postulate. This one just says if two planes intersect, then their intersection is what kind of figure? It's a line. We've already learned this one, okay? Now, the drawing's really difficult. I'm not even gonna try, okay? But I will show you, I'll demonstrate it, okay? So imagine these two sheets of paper are two planes. Okay? Do you see how if we were to meet these two planes up, do you see that intersection, that line? If these were to extend forever, do you see how that line would extend forever? Any way that these two planes meet, it's going to be a line. Okay? Does that kind of make sense? Okay, awesome. Perpendicular, yes. Yes, quickly. Where'd my Apple Pencil go? It intersects to form 90 degrees. That's why we have that right angle symbol there. Do you guys see that? So perpendicular means 90 degrees. It means it intersects at a right angle. So this line can only go in one direction to intersect this board at 90 degrees. Do you guys agree with that? If I tilt it even a little bit, is it perpendicular anymore? No. So it intersects like this. What this is saying is if there's a line that intersects your plane at 90 degrees, any line that you draw on the board that also intersects this line will be perpendicular to that line as well. Okay? So if I take my line and I go through this purple line, they're going to be perpendicular. Do you guys see that? Because the angle here is 90 degrees. Now, if I take this line, it's still perpendicular to the board. Is it perpendicular to this line though? Why not? It doesn't touch the line. Do you guys see the difference? So it has to touch the line, and it has to be perpendicular to the board. Got it? Okay. Example 1. Now we're just doing examples, peeps. State the postulate illustrated by the diagram. You can go back in your notes. What do you think is the postulate illustrated here? Sophia?
Line intersection postulate.
Very good. Line intersection postulate. And Sophia, can you just read that one out?
Like the meaning.
What the postulate says.
If two lines intersect and their intersection is exactly on the plane.
Very good. Do you guys see how we started with two intersecting lines and we ended up with identifying the point where they intersect? It's exactly what this postulate is stating. Do we all see that, kind of? Are there any questions? Okay, what is the second one illustrating? Bryson?
Mainline postulate.
Try it again. Because plane line postulate starts with how many planes?
Just one.
Just one. Try it again. I'm going to have Zach help you, okay?
Alright.
Zach,
Plane intersection postulate.
very good. Can you explain why?
Oh yeah, I remember now. It's not them meeting and forming a line. It's more like it going through.
Actually, those two planes are intersecting. They are. So, Brayson, can you explain it?
You said when two planes meet, it always makes a line.
Very good. Do you see how these two planes are meeting up with each other? And then the second one is saying their intersection needs to be? Their intersection needs to be?
A line.
Oh my gosh. Their intersection needs to be? What is their intersection here, guys?
Perpendicular.
What?
A line.
It's a line. Two planes intersect to form what? A line. Two lines intersect to form a point. Oh boy. Are you guys like just tired or did we not know that?
It's Thursday.
I'd say both.
Okay. Use the diagram to write examples of the plane point postulate and the plane line postulate. Use the diagram to write examples of the plane point postulate and the plane line postulate. Well, let's start with the plane point postulate. What does that one say? Someone go back and read it for me. You're going to have these memorized, but for now, we just learned them. So someone go back. Cody.
A plane contains at least 3 non-collinear points.
Very good. So it started with what in that statement?
A
A plane. So we need to identify first a plane. Which plane do you want to pick?
We'll pick plane CDA. Or is that an N or a D?
Oh, so both the planes are labeled with just one letter. Do you see them?
Yeah, so it's P.
You want to use plane P? I would agree. So it says, I start with plane P, and what needs to be in plane P?
3.3 collinear points.
3 collinear. Are you reading that correctly?
Or
Non-collinear. So let's find 3 non-collinear points. Does anyone think they have 3 non-collinear points in the plane P? John?
BAC.
B, A, and C. Do we agree with John? I do. Okay, that is correct. 1 down. What was the other postulate? The plane line postulate, right? So we did plane point postulate. Now we need to do plane line postulate. Val? If you answer this one. I don't know. Read it. We need an example of the plane line postulate from this figure. Huh? So, go back to the plane line postulate. Go back to the plane line postulate in your notes. What does the plane line postulate say?
If 2 points are in the plane,
So we need 2 points in a plane. Pick 2 points in a plane. B and A. And what plane do they belong to? P. What does it need us to infer from that? Read the rest of the postulate. What's in a plane? There's a line in that plane that contains those 2 points. Guys, what's the line in this plane that contains those 2 points? Line N. Is line N also in the plane? Yes, so we're Gucci. That's not Gucci. Does that mean practice this fancy?
No. Not, it's just like being
Oh, really? Okay. We Gucci? Example 3. Yes, you can go. Which of the following statements cannot be assumed from the diagram? Okay, so we're going through and we're going to decide which ones we cannot assume. A, B, and F are collinear. A, B, and F are collinear.
Yes.
That's true? So can we assume it? So should we pick it as an answer?
Yes.
It's asking which of the following statements cannot be assumed.
No.
So we don't pick it, okay? So we should write next to it that it is a true statement because they all lie on the same line. Do you guys agree? So they are not collinear. I mean, they are collinear, excuse me. E, B, and D are collinear.
no, but they are coplanar.
They are coplanar. I agree with that. Are they collinear, though?
Yeah, they
You
can
could make a line though.
Remember, do we assume in geometry?
No.
Ever? I agree. You could probably draw a line through those 3. Are we going to draw our own line on a figure? Absolutely not. So if it's not on the same line, do we assume it? We're going to say false. And we're going to pick this answer. Are we in agreement? Excellent. A, B, guys, we may or may not have seen this symbol. Does anyone know what this symbol means? No. No, this one. It's, no. Have we ever seen this figure or this symbol before? It means perpendicular. Yeah, it's kind of like an upside down T. Okay? So, and we know what perpendicular means, right? Perpendicular means that it forms what kind of angle? A right angle or 90 degrees, okay? So, is AB perpendicular to the plane S? Is AB perpendicular to the plane S?
No.
Plane B.
AB is this line. Do you guys agree?
Yes.
Is it perpendicular to this plane?
Yes.
It is. Why is it perpendicular? Marcus, you're pointing at something. The red thing, okay? This means that it's perpendicular. Do you guys see that? Now, hey, look. Where does the perpendicular symbol start? It starts at AB. Do you guys agree? It starts on the line and it goes to what?
The red plane.
Do you see how it stops on the plane? That means it's perpendicular to the plane. If it stopped at this line, what is this line? CB. If it stops at the line CB, that would mean that those two lines are perpendicular. Do you see the difference?
So I was going to ask you if AB and CD
Are perpendicular?
are they perpendicular. You would say yes.
Oh, so that's a good question. So that's kind of like the question. Do you remember when I was dealing with the board? So Sophia's asking, is AB perpendicular to CD?
Technically, yes.
Technically, no. Because do they intersect at all? John, do they ever intersect?
Oh, it has to intersect?
They have to intersect. So,
No, because that line is going behind it.
correct. So AB and CD will never intersect. But guys, is AB perpendicular to BC? Yes.
Because it's going behind.
Okay.
Intersect.
Okay, so if this line, right, AB, if this line AB is perpendicular to the entire plane S, any line that's in S that goes through the point B is going to be perpendicular to that line. Does CB lie in the plane S? Yeah. Is CB going through the point B? Yes. So these two have to be perpendicular as well. Okay? This is tough to visualize, but this is a true statement. Are we going to put it as an answer? No. Is CD perpendicular to plane?
No.
Why not? It doesn't have a symbol. Can we assume just because it looks like it's 90 that it is 90? Absolutely not. So this one we would say false, and we would pick it. Do you guys agree? Because it's something we cannot assume. AF intersects BC at point B. True. Would we pick it? No, because this was a double negative problem. It's asking for the ones that we cannot assume. It's a little bit confusing, but it's good practice. Okay, moving on. Example 4. Name a pair of supplementary angles and a pair of vertical angles in the diagram. What does supplementary mean? 180. Who said 90? Guys, we need to do our studying. Okay, so which two angles add up to 180 degrees? Byron, I need your help for this one. TWV alone is how many degrees? 180. We can't pick one angle for it to be supplementary. It has to be a pair. What two angles add up to 180? German?
PWV and PWT.
Good. PWV and PWV. Wait, what? You said PWV and PWT. Yes. Very good. Do you see how this angle added with this one gives me a straight angle? Byron, you said a straight angle, but you need to have two angles that add up to that one. Does that make sense? Okay. Someone give me a pair. We may not remember this. You remember it, Hayden? Vertical? What angles do you think are vertical?
Yeah.
Alexis?
VWQ and PWT.
Excellent. VWQ and PWT. How did you find those two angles, Alexis? What does the vertical mean?
Like the opposite.
They're opposite each other. Do you guys see that? So Alexis picked this angle and this angle right here. Do you guys see how those are complete opposites of each other? Okay. There's a lot of vocab, people. We need to start like, this should be like second nature for us by now, okay? Get with the program. All right. State the postulate illustrated by the diagram. Go back. What? 2-point line? Or it's not the 2-point line. It's just called the 2-point postulate. You'll get it wrong if you say line on the test, though. 2-point postulate. Okay, now, do you think we could remember the 2-point postulate? It starts with 2 points. Do you guys see that? You see how some of them are very easy to remember? Okay, on. State the postulate illustrated by the diagram. The what? Go back. It has a very specific name. Not collinear.
Come on, me.
What? What? The 3-point postulate? Plane. We started with a plane. Then we went to what? Points. So the plane point, and we just put postulate. Do you see which one was very similar to this one? The 3-point postulate. But the 3-point postulate said start with 3 points and make what out of those 3 points? A plane. Do you see how we're starting with a plane and we're saying there's 3 points in that plane? Guys, they're different. You have to be specific. Okay. Use the diagram to determine whether you can assume the statements. John, give me 2 seconds. Planes W and X intersect at KL.
You mean JKL?
What?
Same thing, JKL.
Do we ever use 3 points to label a line?
No. You're assuming again.
So, KL is this guy right here, right? Does KL include the point J? Does KL include the point J? Yes, because what is it? It's a line. Do lines extend forever? Yes, so it definitely includes that point. Is that the intersection of the 2 planes? You betcha. Are points K, L, M, and N coplanar? What?
Where are you getting W O?
Look at the thing. It says plane.
Yeah, W is this plane, and X is this plane.
No.
They do.
They're coplanar. Well, let's find the plane. Let's find the points. K is right here. Do you guys agree? L is right here. M is where? Here. And N is where? Here. Right? Do they all lie on the same plane? They do all lie on the same plane. Which plane do they all lie on? X. How?
Oh, I thought M was like, I thought the M.
What?
I thought the K and M was like going through it.
No,
K and M was going through it. No, K and M, it's dotted because it's on plane X, which is behind W on this side, but it's in front of W on this side. It makes a little bit more sense? Okay. Are Q, J, and M collinear? Why? There's no line going through them. So this one we cannot assume. Put an X next to it. Let's go, guys. Same figure. JK lies in plane X. Yes. If it lies in the intersection, is it part of that plane? You betcha. Is NKL and JKM vertical angles?
Yes.
NKL, draw it, guys. And JKM, are they opposite each other? Yes. They are still opposite each other, okay? All you need to be vertical is 2 lines intersecting. Do you agree that these 2 lines intersected and those angles were opposites? We're Gucci. Are NKJ and JKM, are they supplementary? NKJ and JKM.
Yes, they are.
I think they were looking at the bottom one.
Come on.
They are because it makes it one.
What line do they form together?
A 180.
NKM. Wait, no, that's not a line. Line has to be just 2 points. So you could say it's line NK or line KM. You could say the angle is NKM.
What about NM?
Okay? NM, you can say yeah. Okay, your last assignment. Pick any postulate you want and draw a diagram to match that postulate. Go. Did you just ask me what a postulate was?